So this first potassium lecture is just kind of a little bit of a review or a kind of informative thing on potassium. So, of course, the cations in the body, and cations are the positive guys, so the cations in the body are sodium and potassium, right? So sodium and potassium. And the anions are chloride and bicarbonate. We haven't really talked about bicarbonate other than when we talk about TCO2. So that's the first thing to realize. The primary extracellular cation is sodium, so that one's extracellular. And of course the primary intracellular cation then must be potassium. So it mostly lives intracellularly, and of course that's because, of course, you know that it can cause problems when it's really high. So most cells, so let's draw a cell, are very, very rich in potassium. So they have tons of potassium within the cell. And there is a sodium-potassium ATPase, it's a terrible ATPase, that pumps sodium out and pumps potassium back into the cell. So that's essentially, we want to keep potassium in the cells. So a few things to realize is that the diet, so let me make a leafy green. So here's a leafy green that is very, very, very rich in potassium. But that's okay. So our diet's very rich in potassium, but that's okay because our kidneys are extremely efficient at peeing out potassium. And so the fractional excretion of potassium is around 20%, which is a lot. So we excrete out a lot of potassium on a daily basis. So if you stop eating, you can become rapidly potassium depleted. And if you stop making urine, you can become rapidly hyperkalemic or an increase in potassium. So potassium excretion is determined by a few things, and I'm going to go through those now because it's going to relate to how, when we actually look at alterations in potassium, why we see those differences. So potassium excretion is determined by a few things, and one of them is the flow rate in the kidney. And I think this can be a confusing concept. So, here's our kidney, and so depending on what our flow rate is, if it's very, very fast, meaning it goes through quickly, right? So you're diuresed, that means you excrete a lot of potassium quickly, and that's fine. And we actually use that. We put animals on fluids when they have a high potassium to try and excrete out the potassium. But if you have a slow flow rate, you will actually reabsorb more potassium. So even with dehydration, you'll start reabsorbing more potassium, but you don't become hyperkalemic, of course, because aldosterone kicks in over here to reabsorb sodium and water and excrete potassium. So a flow rate's going to determine the amount of potassium excreted, but it won't cause you to become hyperkalemic. The second thing is functional kidneys. So are your kidneys functioning? And the reason this is important, because of course you need your kidneys to be functioning. So we're going to say kidney function. And are you making urine? So how much urine are you producing? So if you stop producing urine, then you're going to stop excreting potassium. And so you have to make actually urine for it to get potassium out of the body. And of course that also means is how much do you have an outflow. So what is the actual outflow? And this is important when we talk about obstruction. So can you get urine out of the body? And then the last thing is aldosterone. So all of these determine difficulties. Aldosterone, there we go. So all of these things determine actually potassium getting excreted out of the body. So what's the flow rate? How are your kidneys functioning and how much urine are you making? Is the outflow patent or do you have a urinary bladder rupture? And then is aldosterone, how much aldosterone is being secreted? When we see alterations in potassium actual concentration, what we're going to think about is again, the rate of excretion. So we're going to go back to those things we just looked at. So excretion of potassium, and that's going to be via the kidneys primarily, but we're also going to talk some about the GI and vomiting, diarrhea being less, and then in horses' skin. These are not the big things to talk about. It's mostly the kidneys. The next thing we're going to talk about is a shift between the ICF, so the intracellular, and extracellular. And of course, potassium is supposed to be intracellular, so we can see shifts due to acid-base disorders. And third, how much are we taking in? So this can be via intake, through diet, or through IV fluids.